Tool bit, no tool bit. Shaper don't care. Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my A3 switcher locomotive this week and I'm going to finish up the reversing gear, which is the valve gear control system for the locomotive. So technically at the end of this video, this locomotive will be drivable, sort of. So let's go. Here's the so-called reversing lever that we made last time, and it needs to connect forward over here to the radius arm. So we need obviously some kind of redirection there because the radius arm moves up and down. So that's done with a bell crank, and the bell crank is actually a two-part crank. So let's get started with that. I have a couple of pieces of scrap that might save me some work. Very conveniently, all of the valve gear on this locomotive is the same thickness, so I have a bunch of scraps from previous pieces of valve gear that are already pre-dimensioned on one side. Very helpful. I'm going to make these two small radius arms on the same piece using finished reference edges on either side for each piece, so I'm effectively drilling the holes using opposite corners as references. You'll notice there's one extra hole there. That's a very important reference for because shut up, that's why. With the holes drilled and reamed, that's pretty much the most critical dimension on the part, the distance between these holes. Everything else is mostly cosmetic. For the other pair of longer arms, that other piece of scrap turned out not to be big enough, so I, quote, had to use the shaper to plane down another piece of scrap to that thickness. Any excuse to use the shaper. Then I drilled the 4 holes using opposite corners as references for the 2 lift arms once again. So these are the longer pair of arms that make up the bell cranks. Over to the surface plate now to lay out the tapers. These bars are all tapered, of course, as you can see in the drawings. So I'm marking out the tangent points for where those tapers meet the rounded ends, and I'll be cutting to those layout lines to create the decorative tapers. At this point, all of these parts have been cut apart, as you see, but they all have one reference edge that's machined and one bandsaw cut edge. So all of my layout is being done relative to the machined edge, of course, and also using gauge pins in the holes where needed for reference. So with those tangent points set, I can connect the dots, and that will give me the taper cuts that I need to make on each of these pieces. While I still have one flat edge on each, though, I want to do one more feature, and that's an angled slot cut at the end of each lift arm. Each arm has a clevis at the end, but it's not a straight through the part kind of clevis like you normally have. The clevis is at a very high angle, and it's very deep. And this is clearance for the linkages that connect to it. So I centered up on that, and then I put a gauge pin in there to establish a reference for the final depth of the slot relative to the position of the hole, because of course the rest of this part is still rough cut. And this is where I realized I have a problem. The depth that I need here way exceeds the flute length on an end mill this small. This is a 1/16 end mill, so it has a 1/8 flute depth. You know, the 2 times ratio there is pretty common on end mills. And as you can see, I'm nowhere close to how deep I need to go. And in fact, what's shown here isn't even the full depth yet. It was just already obvious I wasn't going to make it. So now I have a problem. Now you can buy, I'm sure, 1/16 long reach end mills that have a higher flute depth, but the rigidity on such a cutter would be so low you would have to take incredibly light cuts, which would take forever, and you'd probably break 5 of them cutting every slot. And I do have 4 of these to cut, and they're pretty deep. So I don't want to be making 200-300 passes to cut each of these features. I'm going to need to find a different way. The next thought was, well, maybe if I lay the parts sideways, same angle but 90 degrees over, first of all, the slot will be a little bit shallower, and from this angle, I can chain drill out the slots, maybe. And that will save me a lot of milling work, and if all else fails, I can chain drill and file the slots. So because it's at an angle, I need to mill a flat spot for the drills, and I started doing that and immediately realized this won't work either. I'm not even going to get one full drill width of chain drilling room with my flat spot before I start cutting too deep and I'm into the actual part itself. So there's really no way to do this either, except maybe using that 1/16 end mill again to create the flat spot, but that's just not going to work very well because of the length of the slot and again the depth I need to reach, so this isn't going to work either. Plan C then was maybe I can do this on the shaper. So this is the direction of the groove, like so, across the part. And if I used a tool something like this, a grooving tool, similar to what you'd use on a lathe, then I might be able to set it up on the shaper. I'm finding the edge of the part with the edge of my tool, like so, and the backlash is preloaded in the direction I'm going to be feeding. Then I zero the hand wheel there, and a little bit of arithmetic tells me how far I need to feed over to get the tool centered on the workpiece. So I feed over that amount, and then I just need to feed down from here. That grooving tool has been ground to be the same width as the final feature that I want, so it should be a single pass vertical cut right down to final depth. I opted to go pretty slowly on this because it is a fairly wide aggressive form tool, and I do need to feed down by hand, so that's easier to do if the machine's running slower. And as you can see, this is working great. The machine is having no trouble at all with this. It's making a beautiful slot. Because this is a wide, flat cut, I am taking light passes, just a couple of thousandths, similar to what I would have had to do with a long reach end mill. However, here it's a couple of hundred strokes on the machine, 1 second per stroke, something like that. Whereas on the mill, every single pass is a lot of fiddling around, probably a minute of messing with the power feed and adjusting depth of cut and so on and so on. Here's the real money shot. You can see how nicely that's cutting, and you can see the clapper box really earning its keep there. Of course, there is clearance for the tool on the backstroke because I'm cutting vertically, but because the tool is the same width as the slot, any tiny little burr or anything in the cut is going to snag the tool on the backstroke and cause it to lift all the way up like that. So that's why you see so much clapper box movement, even though these are very light cuts. My reference for the final depth of this slot is the hole, because of course the rest of the part is still rough cut. So once the shaper has just reached the bottom of the hole, which is plainly visible on the part, then I use a pair of gauge pins to measure my depth of cut from there. So I can calculate on the drawing what the distance from the bottom of the hole should be to the top of the slot, and use a gauge pin to measure my progress towards that goal. So kind of old-fashioned method, since of course I don't have a DRO on the shaper. I mean, you could put a DRO on a shaper, there's nothing preventing that, but don't have one. That all looked easy, but it was definitely some trial and error. I mean, I did 4 or 5 iterations on the grind on this tool. You can see that I didn't have enough clearance for a while on the left side of it. You can see that it's rubbed on the top of the part there. Luckily not enough to damage it, but it also took me a couple of tries to get the end clearance right. In the cold open, you saw I snapped the first version of this tool. That's because I had too much end clearance. I had about 10 degrees of end clearance, and really the shaper wants more like 3. And that matters on a shaper because you need that strength of that material behind the cutting edge, or else it will flex, and it will flex until it breaks, which is exactly what happened to me. That's one thing I've learned about the shaper, is that it is much fussier about all your tool clearance angles being dead nuts correct. The lathe is very forgiving on that. The end clearance on your tools is 5 degrees, 10 degrees, whatever, it doesn't matter. The shaper wants 3 degrees, and they are serious about that. But this was an amazing learning experience for me grinding a form tool on the shaper. You can see the result is fantastic. It was a very difficult feature, a very low angle, very deep slot on a small part, but the shaper nailed it, and I learned a ton about how to do some tricky operations on this machine. Also, score 1 for the shaper. This is my first official job that it did that the milling machine could not do. I'm being a little facetious. Of course, the mill is technically capable of making those cuts, but the shaper was a whole lot easier, that's for sure. It's not often that the shaper is better than the mill at something, but it does happen. Then the angled cuts I finished up on the shaper as well. Very simple decorative cut. I am getting better at finishes on the shaper. I massaged the grind on my roughing tool a little bit, and you can almost see the reflection of the scale in that. You can just start to see the vague images of the numbers. So finishes are getting better on this machine. I'm getting the hang of it slowly. So with all 4 of those cut, all the tapers done, I then went over to my bandsaw fixture to round the ends. That's it for my 4 little lift arms, all ready to go. I would never have guessed how tricky that angled slot would be to cut. Wow, that was a doozy, let me tell you. Next up is the reach rod, which connects the reversing lever to the bell crank. This is very simple, made even simpler by starting with ground bar stock, the correct diameter. So I just have to put a couple features on the ends. You'll see me making heavy use of one of my aluminum adapter collets for this because the dimension of this round bar is a bit of an odd size, 5/32. I don't have any collets or anything that dimension. This is a two-piece bar so that it's length adjustable. So there's a long main part and then a little end part, and they thread together. Then they each get a little flat tab at the end to join up to the linkages. I'm skipping through this quickly because these aren't interesting parts. For once, I successfully planned ahead on these and special ordered the unusual diameter ground bar stock for these parts, so that made them very simple. This would have been a very difficult part to make if I'd had to turn that weird diameter all from larger stock. I'm also going to skip over the drop links, which go from the bell cranks down to the valve gear, because these are exactly the same as the union links in the valve gear itself. So go back and watch that video if you want to see how these were made. Next part is a little tricky. This is a connecting bar that goes across between the two bell cranks. It goes across the chassis under the boiler. So it has this crazy curve to clear the boiler. I ended up drawing this in CAD to 1:1 scale. I tried scaling up the drawing as you see above, but that didn't work very well because of the weirdnesses of printing photographs. So instead I just drew it again in CAD and got a 1:1 drawing of it so that I can use this as a bending guide. So starting with a piece of bar stock that I know is well over length so that I can make errors in where the bends all end up, I'm going to do this on my slip roll, which has these little dies at the end for bending bar stock. I've never used this feature on this machine before, but this seems like a good excuse to try it. So I've marked the center and the end points of this first curve, and I'm rolling back and forth between the end points a little bit at a time. I'm not particularly experienced or skilled with slip rolls, but one thing I have learned is don't get greedy. Take your time, go a little bit at a time, and you'll get much better results, and you won't overshoot the curve that you're aiming for. The little dies on the ends of this machine are kind of a nice idea, but honestly, they have one main weakness. Because the die is only on the lower roller, it's not on the upper roller, this process does tend to put a flat spot on the bar, especially if you get too greedy with the pressure. So it did do the job, it's making a nice curve, but the final bar did end up with kind of a flat spot on the top. So a bit of a compromise. It's not a proper bar roller, this thing. You can see I have a little bit more to go there. But in a pinch, so to speak, it does work. And this bar won't be visible anyway. It's completely down inside the chassis and under the boiler. So if it's got a little bit of a mangy flat spot on the top of it, doesn't matter. The other advice I have for rolling features like this is to start in the middle and work your way to the ends, because the most challenging part of making bends, especially on a slip roll, is getting them in the right place. And if you start in the middle and work your way out, you have a lot of margin for error on centering your bends. That's looking good now though. I'm using my center line to check the fit on every iteration. And now I need to do the curves on the ends, which are too tight for my slip roll. So I thought I'd try my little tubing bender on a test piece, and that did just fine. It's kind of definitely at the limit of it. It's just an aluminum tubing bender, but it did manage on this bar stock, so not too shabby. It can manage those really tight bends, but as is usually the case, I got it in the wrong place. So I had to shift everything over a little bit, but that's okay. That's why I have all the extra material on there so I can make those mistakes. And that's also why you start in the middle. So for this final bend, to be more careful about exactly where it ends up, I'm using this technique where you drill a hole through a piece of bar stock, put a very generous chamfer on it so that you don't put kinks in the material, and you very gradually pull on it a little bit at a time, moving the piece between each movement, and then you can generate a curve like that. The curve you get is not quite as nice as the other types of bending tools, but you have a lot more control over exactly where it ends up. So that's my final piece, looking pretty good. I need to straighten the ends a little bit, but I'll cut it to length now, rough cut that is, with a hacksaw. And then I finished it to final length over on the milling machine, measuring end to end with a big caliper, because the final overall length of the bar is fairly important. Next up is the brackets that hold all of this. So once again, I went back to that original piece of scrap that I had, and I figured with some very careful layout, I can just squeeze both of them in here. They're triangular in shape, and I was able to lay them out on here with one piece and have just enough room between them to cut them apart at the end. It was close, but this saved me a lot of work again having to thin down a piece of stock to the overall thickness of this bracket, which is once again the same as all the valve gear. So again, each piece has its own little reference in opposite corners, reamed the holes, and then while it's still square, I put it up on end and I drilled and tapped the mounting holes for each of these two brackets. Then I very carefully cut them apart on the bandsaw. I had about 20 thousandths of clearance on top of the kerf of the blade to do that, but was able to do it, got it done, cut them apart, and then cut the tapered sides on the shaper, of course, because it's the shaper. And predictably enough, the ends were rounded on the belt sanding fixture. Here are all of the components now of the reversing gear. I didn't show you these little pins, which are very simple. You've seen me make little pins like that on this channel thousands of times. Hilariously, this is the moment where I realized I only needed one of these small lift arms. I made two of them because it's a locomotive. You're making two of everything all the time. I didn't even check the quantities on the drawing. I just was on autopilot and made two. So the extra one will go in the parts bin for the locomotive. The next job to do is to set the angle of the lift arms on that bent crossbar. The drawing suggests doing this with a template of some sort, so I made a little template out of some cardboard. The angle is supposed to be 112 degrees, so I made a template at that angle with some cutouts to account for the radius of the bar because it's 112 degrees from center line to center line on the two bars. This was a little tricky. And well, I mean, I did get it set this way, but as you'll see in a second, this was all a giant waste of time. There's a much easier way to do it. There's little set screws in the ends that just temporarily hold the angles. These linkages will all be cross-pinned. There's the bar and the lower lift arm assembly all together, and I'm bolt that in place now. You can start to see how the lift arms combine to form a bell crank. On the outside are the lift arms that move the valve gear itself. And then on the inside, there's a shorter lift arm that connects to the reach rod. And when those are all set at the correct angle, that forms our bell crank. The drawing gives nominal angles for all of these bars, but I realized there's an easier empirical way to set it. So I connect the drop links. You can see the whole mechanism in action now. And what I realized is if you just set all the linkages in situ on the locomotive and mark where they're supposed to go, then you know everything will be right, and that's a lot quicker and easier than guessing with angle templates and hoping that everything is right. The lower lift arms have no adjustment in them, so they have to be set first. So I set those to where they had the correct range of motion for the valve gear to go through its full travel, and then I scribed the angle of that arm on the connecting bar. Then I flipped the locomotive around and did the same thing on the other side, again independently. Disconnect the first arm, do this arm now independently, so that the two arms can be a little different if they need to be. They shouldn't need to be, but just in case. Then with those angles marked, I then cross-drilled and reamed and pinned the bars onto the arms. And the nice thing about this is I don't have to worry about them moving during this drilling. They're just held on with those tiny little set screws, which aren't very strong. However, because I have my scribe lines, I know if they've moved, so I can keep an eye on that, and I know what angle they're supposed to be at. The pins themselves were just made from ground bar stock, cut and filed to length, no machine work there. And those pins will be Loctited in place. I did the same procedure for the third lift arm, this time connecting the reach rod to the reversing lever, making sure the reversing lever has full range of motion and that everything's moving correctly. Mark that position, drill and pin it in that position. If you're wondering about that fixturing, one of those brass blocks has a V-groove cut in it, so that's why I was able to hold on to those bars so easily like that. That little V-groove was the secret. It was quite an easy setup with that, and that's all very, very strong on there. And the nice thing about this approach is you could also use a roll pin or something like that, but the nice thing about these pins is that they're easy to insert. The Loctite will keep them from going anywhere, and if you ever need to get them out, a little bit of heat breaks the Loctite, the pins fall right out again. There's no hammering out roll pins or anything like that. At this point, the length of the reach rod can also be adjusted if needed. Next, we need to cut the notches on the quadrant, and these are determined again empirically, according to the drawing. The drawing has some elaborate instructions for determining where the mid-gear, full gear, and full reverse gear positions are, based on looking at the positions of the crank pins and the positions of the valves and so on. I won't bore you with those details, but I determined the locations of the three notches and scribed them onto the quadrant. And then they're cut onto the quadrant with a lot of filing. This is obviously fairly time-consuming, but honestly, it really is the easiest way to do this. trying to set this up for some kind of elaborate slot cutting operation on the mill with the weird curves and making sure it ends up exactly on your scribe lines, that would all be pretty difficult. So technically, filing was easy, even though it was more laborious, if that makes sense. But the nice thing about the filing is, although it is a lot of work, it guarantees good results. There's the 3 primary notches, the mid-gear position there for high-speed cruising. Then I can squeeze the little handle and pull it forward into the full forward gear position, which is where you would be for starting out or accelerating. And then if you need to go in reverse, you can notch back all the way, and there's your reverse gear position. Real locomotives, of course, have 8 notches. That's the standard, not just 3. And a person could theoretically add a couple of intermediate notches here to make it 5. I'm honestly not sure if that's necessary. The drawing doesn't say that it is. I've never driven a 3.5-inch gauge steam locomotive before, so I don't know how necessary the intermediate notches are. I suspect not very. I think it's probably just going to be running in full gear all the time. It's pulling a lot of weight for its size, but I can always add notches later if I want. And of course, you can still use intermediate positions on the lever if you want. It just may not stay in that position of its own accord without a notch in that position. This is really cool now, though. You can see the full motion of the valve controls in action with all of the little linkages and the bell cranks and everything all doing their jobs. This kind of thing never gets old. So much work to get to this point in the mechanism, but the result is really satisfying. Everything works so nicely. It's a very cool mechanism. It's not something you're going to get to see in action like this up close all that often, because it's just sort of going to be a blur as the locomotive goes by, but it's sure neat to see it all working. I'll get the boiler on here too, so you can see how the curve in that bar is crucial to get underneath the boiler. The exact curve isn't that important, it just needs to clear the boiler, and there's plenty of room for it to do that, but that is of course crucial because the boiler is in the way for a lot of the controls and mechanisms in a steam locomotive. Now we got to fire up the compressor and test it, right? Here goes. Yeah, there's full forward gear. Notching back. There's full reverse gear. That's looking really good. Of course, the middle notch just ends up stopping the locomotive because you don't have any forward velocity for the locomotive to be coasting on. That's when you would be using the middle notch, but since we're stationary and the throttle is low, which is the air valve in this case, mid-gear just stops it. And sorry for the compressor noise, there's just really no way to do these tests without the compressor running. My compressor is very, very small and it has nowhere close to the CFM needed to run a locomotive. This is like a giant air tool, basically. Well, there you go. There's the full valve gear control system now in place. This locomotive is more or less technically drivable now, which is pretty awesome. Very excited about that. We got lots more infrastructure to do before we can do the first real steam test. That's the next milestone. But it's starting to look like a boat now, I think, and I'm really enjoying playing with the valve gear. It's super fun to drive this locomotive in some capacity. Well, thank you very much for watching. Thanks for your support, especially to my patrons who keep this content going week after week, and I will see you next time.